Hello everyone. As Mohammed said, my name is Sumit Kumar. I work at Microsoft. I am a program manager in the machine learning group at Microsoft, and one of the things that I do is integrate Python and R in SQL Server so that you can do in-database machine learning. And today I'm going to talk precisely about that, in-database machine learning with Python. So welcome again. And how many folks here are from outside of Seattle? Quite a few. So Seattle is beautiful like this always. Never rains here. Thank you for bringing the nice weather. All right. So here's the quick agenda. I will introduce the concept of in-database machine learning and why does it really matter and what are the advantages. And I'll walk through a lot of concepts using a demo where I do the prediction of the length of a patient's stay at hospital based on the historical and other data. And then I'll touch upon various scale, performance, and security aspects, etc. And I'll try to save about 5 minutes in the end for question and answers. And I'll stick around afterwards as well for any other questions. And if we have more time, I'll cover some other bonus materials. How many of you here use SQL, the language, on a regular basis? About half. How many of you use SQL Server, the product, a database product? About a third of folks. Of course, everybody uses or is interested in Python, so I'm not going to ask that question. Anyone familiar or heard about SQL Server R services before? About a third. That's good. OK. So you might have seen this most recent survey from KD Nuggets about the popular tools and software used in data science. And as you can see, Python, R, and SQL are the top three. And of course, Python is the top one this year, and it has been the fastest growing over the last 3 years. So what we are doing with SQL Server machine learning services is bringing these top languages closer to the data right there in the database. And you can combine Python and SQL in interesting ways, Python and R and SQL in interesting ways to leverage the strengths of the different languages and achieve sort of more efficiency and performance and scale. And the idea overall is that the paradigm in the past was that database is used to get the data, and you pull the data in your application, and you build the Python-based or R-based intelligence and models in the application, and that sits in the application. And there are lots of issues involved in that I'll talk about in a bit. From that paradigm to the situation where you move the intelligence and the models right where the data is in the database. And that data, the intelligence in the models become another enterprise asset that any number of applications can just get access to that intelligence by connecting to the database. So from a regular database to intelligence base, intelligent database is where we are trying to go. So building further on, why does it matter? Why not just use ODBC or JDBC to connect with data and do it, right? I already touched upon this a little bit. First, and the biggest advantage is rather than taking data to the compute, you bring compute to the data. You're eliminating data movement completely. There are a number of benefits just from that. Moving data, massive amounts of data that are required for machine learning, deep learning type applications is often is just not easy to do. You have to build massive amount of data movement infrastructure. That is, if you're allowed to do that. Many times, because of the security and the compliance restrictions, it is just not allowed. You cannot move data around. And even if you are allowed to, you're often forced to move samples of data. Then you are, as a data scientist, you're limited to working with samples. That means in some algorithms, in some cases, your accuracy is hampered because of the amount of data available to you. And there are all sorts of sort of security concerns, etc. Right? So if you're working in database, you are able to do your training and model development in database. A lot of those issues are just gone. Now, once you've developed the model and the Python scripts, putting or R scripts. By the way, whatever I say about Python applies to R as well, because we've added R in 2016 release of SQL Server, and in upcoming 2017 release of SQL Server, we are adding Python support as well. So let's say the data scientist team has now built beautiful models. Putting that in production where it is available to all the apps is where a lot of challenges involved, right? So we've heard stories from our customers where the data science team would build the model and hand it over back to the app developer team, and then application development team would literally translate that model and coefficients, etc., into the language of application, be it Java, C#, etc. And there is fidelity loss in that, and then the latency involved in sort of translating. All of that cause a lot of pain in the overall process. Whereas if you now do operationalization using SQL Server, what you're doing is you're embedding the Python code or R code right there inside a T-SQL stored procedure, and the applications just make a T-SQL stored procedure call and get all of that smarts without oftentimes even being aware that something of that sort, there is Python or R code running in there. And then the models just become, a binary data that you store in SQL Server as well. And managing different versions of models and doing A/B testing is all substantially simpler by just sort of using different versions of binary data stored in SQL tables. The third advantage is the enterprise gradeness of all of this, right? First, we built on top of the open source R and Python, and we have a couple of libraries. One of them is RevoScale Py, and other one is Microsoft ML package. I'll talk more about that in details. But what they do is they offer a number of parallelized and scalable algorithms for common predictive learning tasks and machine learning. And then they're able to leverage all the cores, and they are able to do MPI-based parallelization. Because of that, they can scale to data that is much larger than what memory is available to it. And then SQL Server itself has decades of innovation in performance and scale and security, resource governance, compliance. All of that now becomes available to your machine learning models and algorithms as well. So one of the things, for example, is the in-memory querying capability in SQL Server and the column store indices. Now you combine all of those innovations with the scalable parallelized versions of RevoScale Py algorithms, then you really get tremendous amounts of tremendous performance advantages. All right. So jumping into what exactly do we get when we install SQL Server. In the SQL, it is integrated completely with the product, including the setup. So machine learning services is just another feature in SQL Server. So you have the option to choose either R or Python or both. So if you choose Python, what you get is, you have to go through the consent screen, and you get a subset of popular Anaconda distribution. A subset of that package is included as part of the setup. So let me actually show you some code and how does it look. Duplicate the screen. So running Python code, just taking a Python code and running it in T-SQL, inside of SQL Server in a T-SQL script is just as simple as pasting this bit of Python code, hello world, inside of a in script under sp execute external script. If I run this, I get hello world as expected. So what this is a special system stored procedure that understands the code for different languages, Python and R, right? But then we didn't build just the simple, lift and shift type thing. It offers some additional sort of tight integration with SQL. So again, this is a slightly more complicated version of example of a T-SQL stored procedure with embedded Python code. Here I'm just doing a simple subsetting. Okay, but what I'm doing here is I can pass any SQL query, the results of any SQL query as input data to this Python script. I can also pass a number of parameters. Like I'm passing, in this case, I'm passing an input parameter and an output parameter. So if I, again, run this thing, now I get the subsetting of that temporary table that I've built before. Any questions at this point? Yes? Say that again?
I see both of the examples you showed, it prints things, right? So it returns now. Can it return things?
Yes, absolutely. It can create a return output data set as well. I'll show more complicated example later.
Yes.
All right, so a little bit about sort of how what the architecture looks like. This thing works. We have integrated the Python and R runtimes in the database, as in it's not running inside of the SQL Server process, but in the database server machine. So what happens is when you saw that sp execute code, is my mouse cursor visible? No? Okay. Let's see now. Okay, here. So when the execution, when it sees the special sp execute external script system stored procedure, what SQL Server process does is, there is another process that we have built called service that keeps running called launchpath service. It then invokes an external runtime through appropriate launcher based on the parameter language. In this case, it's Python, so it launches the Python process. And this Python process is sort of a separate process now, running on the same machine. And this is running under a different local users, with local user called MS SQL Server R01, which has very low privileges to ensure that the Python code script cannot do arbitrary things. And then when the RX or the RevoScale Pi or Microsoft ML algorithms are used, then it invokes another BXL server process running in there, which basically runs all the algorithms in native code, C++ code. And then this has a high throughput columnar data communication channel with SQL Server process to have a direct, high fast communication. That's how it achieves a lot of performance scale. Okay, so I talked about in addition to this integration, tight integration, I talked about a couple of libraries in the form of packages. So one of them is RevoScale Pi. So Microsoft acquired a company called Revolution Analytics. Some of you may have heard. I have people who used to work there right in this room. So as part of that, we got this library. Now we have a Pythonic version of this library. And what it has is a number of algorithms that work in a, scalable and performant way. I will show exactly how it does that. It has linear and logistic regression, trees, forest, boosted trees, and etc. And in addition to that, it allows you to work in different compute contexts. For example, you can work locally on your client, or you can work on a remote server, including SQL Server in this case. And in our case, we have other things, but we are building additional compute context for Python. And it also has a bunch of other concepts like data sources. You can point to a ODBC data or SQL Server data, or there is an additional sort of XDF data source that sort of has a again very on-disk highly compressed columnar data structure that we have, and then it has SAS data step type of functionality, and it gives you additional utilities for data import, summarization, etc. Right? So how this thing works is, calling a RevoScale Py function is very similar to calling the other regular Python functions, analytic functions. But internally, what it does is there is a initiator component which takes care of distributing the job across multiple different tasks, and then each task gets chunks of data from disk loaded onto the memory. So basically, because of that, you can work with arbitrarily large data sets. You are not bound to working with data sets that fit in your memory. And the entire thing is written in Performance C++ code, so that's how you get additional performance advantages. And as I said before, you can either work on this on the local data, or you can work on the remote compute context. I'll show one example later as well. So this whole thing is called parallel external memory algorithms. Similarly, the other library that we have is basically sort of a collection of Microsoft's internal battle-tested algorithms that we have harvested from different parts of Microsoft products, some from Bing, some from Xbox Live, etc. And we have packaged that in this library, and we are making it part of SQL Server. So among other things, it has a deep neural net, for example, which you can use to train deep neural nets. And in addition to these algorithms, we now have some pre-trained models that are available for you to consume right away. So for example, training an image featurizer is a very complex thing. It involves expertise, massive amounts of computing resources, and so on, and time, right? This library includes a number of award-winning pre-trained image featurizer models like ResNet 1850, 101, and AlexNet, etc. from Microsoft Research, which is available to you without any effort. The other pre-trained model that it has is called sentiment analysis model, where from English text it can extract sentiment scores. And then in addition to these things, it also has a number of transforms, extracting n-grams from text, doing categorical transformations and feature selections, etc. All of that is available to you. So I'll now get a little, show you a demo with actual working code. In this demo, I'm going to, I talked about it before, I'm going to show you an application that relies on the predictions of the length of stay for a patient when the patient is admitted. And I'll show how we have done the training. But before that, this is how sort of the workflow is, right? So as a data scientist, you're working in your ID, PTVS or PyCharm or Node, whatever it is, right? But I don't want to pull data there. I want to be able to work on the entire data set that is available in my database. So you can just work remotely and do remote compute context into your SQL Server machine. And your script, even though you are in your ID, the actual execution is happening on the SQL Server box, and results are returned back to your ID. So you're able to do complete experimentation, exploration, and model development right there in your ID. You don't leave your familiar environment. And you can leverage the sort of additional compute capacity available on the SQL Server machine, which is in general higher than what a data scientist's client desktop has. So that's the data scientist part. Now, when you're happy with the model and you are ready to operationalize again, you put that model in T-SQL stored procedure with an embedded Python code with a model, and the application or reports or dashboards are just making a stored procedure call and getting the results back. Imagine sort of the traditional 3-tier architecture where you have the thing in between, and maintaining version consistency and all of that is very problematic there. So you don't have to worry about any of that. The app, in fact, isn't even aware that something like this is happening. Okay, so let's switch to that demo machine. So what you're seeing here is a Power BI desktop version, and it is a dashboard, an app for in the healthcare system where hospitals, unlike hotels, for example, when you check in, you kind of know the length that you're going to stay, and the hotel management or staff can accordingly manage their resources that way. But in hospital, you don't know whether you're going to be there for a day or a week or longer, and so for the administrators and doctors, it is a little bit of a challenge to make sure that they have allocated the right kind of resources and staffing. So if they are able to predict that, the length of stay, they can make a lot of adjustments and gain efficiencies because of that. Right? So for example, this dashboard is for a care line manager who's responsible for specific wards. So if she wants to know, hey, how many people are going to be released in 6 days from now? And so 6 days in general. So she knows from that oh, Saturday she has a lot of patients getting discharged, so she better have the discharged nurses lined up on that day, right? So she's able to make that kind of business decisions based on this prediction. Similarly, for different persona here, the chief medical information officer for that hospital, he can look at the average length of stay and the number of patients that are going to be in different wards, and he can shift around resources, doctors, nurses, etc. accordingly, right? So I'm not going to go too deep into the actual business problem, but the point here is that the business problem was solved based on this prediction that we were able to make. So as a data scientist, I work in my IDE. Here. So I'm using VS Code, and I do the regular things here: data pre-processing and feature generation from the data that I have. I'll not dig deep into all of that. And then I do the training. Let's walk through this code a little bit. So in this thing, I will connect to database and get the data that I need to do training. I split the data into training and evaluation set, and then I train a couple of different models, random forest and boosted tree models, and then I do predictions based on that on my test data and evaluate and compare. And when I'm happy with that, then I am ready to put it in production, right? Let me just run this thing and then show you the code while this is happening in the background. So the interesting bits of code are here, for example. So now this line is where are you guys able to see the code clearly? Okay. So this line is where I'm setting the compute context to SQL. Somewhere above here is so I'm defining the connection string using which I'm giving it the right sort of connection to the SQL Server where I'm working. And then here I am setting the compute context to SQL. That means the subsequent lines of code are actually not being executed here. It is the execution is happening in SQL Server. So here I'm training a forest model using RxDeforest algorithm, and I'm giving it the formula which I have defined before, and I'm specifying other parameters of this algorithm. And when the results come back in the local Python memory in this environment, I now need to write that model back into SQL Server. So I use the RxWrite object API. Again, this is part of ReverScale Py package to write that thing in a SQL table. Similarly, come on. Here, I do the exact same thing. I am training a boosted tree model, and I'm writing the model back into SQL Server table. Down below here, I am doing the prediction on the data using the model that was stored in SQL Server and on the evaluation data set. And I do the predictions for both forest model and for the boosted tree model. And I do the comparisons to see which one has a better performance. Let's see if this is completed running. So the execution here is done, and I see that the error based on that, like error for the random forest model is better. So the random forest model quality seems to be better. I'm now happy to sort of ready to put it in production. So then what I do is I go into SQL Server. Come on. So I can do the entire training and data processing, everything in here as part of the embedded, as part of with T-SQL stored procedure with embedded Python code. But I'm not going to show the repeat of all of that. Let me show you how I do the scoring. Now, the random forest model, all the models, data, everything is securely stored inside of SQL Server. The data is never leaving. It's in SQL Server tables. In this case, I am going to use the random forest model, and I'm giving it a query. I'm select star from the LOS table, which has the features that I prepared in the feature generation step, and then I'm creating a output that is populated in a data set that is being used by the that Power BI dashboard. So if I execute this, it is actually calling a stored procedure called score. So let me show you what's happening in that stored procedure. So it came and it did the generated the data, output data. So this is where the let me hide this thing for a second. So this is an ordinary looking T-SQL stored procedure, right? But in there, this is the new system stored procedure that I was talking about. It takes Python language as a parameter and a script which is under this thing. I'll show you in a bit. And it is taking model name. That was another parameter that was passed by the driving script. It takes the model, and it is taking the inquiry, which was the select star statement, and it is taking database name and some other parameters, etc. And it is passing all of this into this stored procedure, which basically has the same the prediction code that I showed you in the ID. So exact same code running inside of T-SQL stored procedure and doing the things, right? I'm doing the exact same set of things here. So, so that's sort of how using this integration, you can do both from your ID as well as inside of T-SQL stored procedure, and the apps are now sort of able to generate reports, and this is sort of the end-to-end story here. Any questions? Yes, go ahead. Can you speak up a little bit or come closer?
So how's this going to work like the MRS? So is this going to work like our MRS currently does, where you have a free version, an enterprise version?
So how does the licensing work is effectively what you're... So this is part of SQL Server. So you don't pay a dime extra to get this feature. So now, and it is available in all the editions of SQL Server, Windows only thus far. So if you have an Express SKU with advanced features, you get it. But the performance is a little bit throttled. If you have already paid for an enterprise version, we'll give you the fully performant version of it. But you don't pay anything extra for it.
That's pretty cool.
Yeah.
And as far as, I saw it was called ReroScale Python or whatever. So is the compatibility going to be the same between, say, MRS with operationalization, snapshotting of the repos and all that?
Absolutely. But I didn't talk about all of that because we are still working on those things.
That's fantastic.
But as I indicated initially, sort of our goal is to have parity with what you see in R. Okay. Any other question? Okay.
Hi. My question relates to storage and scale. So because we're talking mostly about big data, possibly unstructured and all that, I'm not aware that SQL Server storage currently supports, unstructured data. So I suppose the question that arises out of here, if you're doing this in the cloud, I'm assuming that you spin up a VM with a SQL Server instance on the VM that has our services on it. Then the question arises as to where the data that that's going to serve as your input is going to sit. You could potentially have it in a blob storage, say in Azure or elsewhere. I just wanted you to talk about that whole scenario and how it will work, because data can and do live in all sorts of places. The way we've worked with SQL Server traditionally is that the data that you want to process for analytics purposes tend to sit in the SQL Server instance storage. So how does Microsoft R services, SQL Server R services support working with extremely large-scale data potentially stored outside of the SQL Server itself?
Sure. Excellent question. So first of all, the reason why we have integrated the machine learning services in the database is for you to be able to do advanced analytics and machine learning on the data that is already there in SQL Server, right? So in a lot of cases, people have the entire data in SQL and then they are moving it around to do that. So that problem is solved, and that's one of the main goals. Now, what if your data happens to be outside of SQL Server? And the question is, in that case, why do we want to do it, the analytics or training in SQL Server? There might be good reasons for it. So there are some options for that. If you want to pull the data in SQL Server, you can do things with Polybase is a way to sort of connect additional data sources into SQL Server. Now, if you want to there is an interesting scenario here where it's the hybrid scenario where you're training the models on big data elsewhere, on the cloud, on Hadoop clusters, and then you take that model and you operationalize that model in SQL Server. Now that is a more likely and common scenario. So for that you have a few other alternatives, like for example on HD Insight, we have R server running there, and in future we will have Python as well. Or on-prem Hadoop cluster, you have R server there. So you train your model on big unstructured data, and then your model is ready. You deploy that model in SQL Server where your online transaction data is coming, and then you score. If you talk to me afterwards, I'll show you a demo of exactly that, where we train a model on HD Insight, operationalize it in SQL Server.
I have a question. Understood the writing the code. So when you are showing the BI application for this scenario, when we have Python or R, how the interfaces are connected to the BI?
So this is standard Power BI desktop connecting into SQL Server and getting that. So that has got nothing to do with R or Python integration. It's just a output data table that was created based on the predictions from that algorithm, and then it's just hooking up that data. So it is just another column that says predicted length of stay, and it's just reading that thing. So I'll move along because I think I have just 5 minutes left. I want to talk about, so the developer, so the developer is happy, and the data scientist is happy. There is one important constituency, which is the database administrators. How they don't want any random third-party runtime running in their machine. So we have made sure that we address their concerns as well. So by design, it is very, very secure. So we make sure that this whole sort of the external script execution is disabled by default. So only when you explicitly enable it is this allowed. And as I showed in the architecture diagram, it is running in a separate process. So no matter what the Python script does, it is not going to impact your SQL Server process itself. And even if the script execution is allowed, the specific users need explicit permissions to do that. Just because you can access the database, you cannot run these scripts. And so that's another level of control. And as I said before, the Python and R processes run under, make sure that these are isolated processes, and they are running under very low user, there is a special local user that is created, which has low privileges. You can't, that script can't even, it's running behind a firewall, so it cannot do communications with external network and so on, right? So we have made sure, and then two separate processes running, Python script cannot talk to each other. So we made sure that a lot of isolation and other things are in place. In addition to this, we have resource governance, like the traditional SQL Server resource governance functionality is now extended for the external resources also. External runtime as well. So you can do things like, by default, about 20% of the memory is allocated for external processes, external runtime, but you can change and you can reduce or you can increase it. You can even determine the, do things like CPU affinity and so on. So there are a lot of DMVs built into in the system for you to monitor these external runtime, etc. So basically, we have made sure that DBAs are okay with running these things as well. I think I'm at the end of the talk. And so I encourage you to try out the CTP 2.0 version, CTP 2.0 and I think later versions of SQL Server 2017 that has this thing. And there are a bunch of samples that we have put out. And provide feedback to us. My email address is sumit.kumar@microsoft.com. And Mohammed mentioned the title was changed in the end because I was supposed to do a deep learning app demo in this talk, but I'm going to do that demo in Joseph Sirosh's keynote tomorrow. So if you're around, please come for that, and I'll show another application running there. At this point, thank you so much for your time.